we're continuing with section 15.2 and subdividing the regions again. More general regions, subdividing the regions. Let's look at this region E to the left, and that's basically bounded by x equal to -1, y equal to -1, x equal to y minus y to the third, and y equal to x plus 1 to power 2. So your first instinct, you divide the regions into 3 pieces, one in the first quadrant, then second one in the second quadrant, and the third one in the third quadrant. And so set those up, basically, let's say column T, U, and V, first quadrant, second quadrant, and third quadrant. For T, you can basically, it's horizontally simple for sure, and x goes between 0 and y minus y to the third, and y between 0 and 1. And V also is horizontally simple. X goes between -1 and y minus y to the third, and y goes from -1 to 0. It's easier for just looking at it. You may want to set it up as a vertically simple region. So U in the middle, y between 0 and x plus 1 to power 2, and x between -1 and 0. So you set this up and you write the integral over region E is going to be three integrals of over region T and U and V. Now, is this the only way we can do this? Actually, it turns out that this region can be divided into 2 simple regions. And what are the 2 simple regions? One is basically R in the first and second quadrant together, and the other one is S in the third quadrant. And both of them are going to be basically horizontally simple regions. So the top one, you have to solve for x in here, and if you solve for x, you get square root of y minus 1. And so x is between square root of y minus 1 and y minus y to the third, and y is between 0 and 1. And then the part that is under the x-axis, x is between -1 and y minus y to the third, and y is between -1 and 0. Note that both R and S are horizontally simple. So now you set this up according to that, and then you solve if you have a function in there. Now, I clear question 15.2D. Let D be the semicircle shown. What is the smallest number of simple regions that D can be sliced into? And so A is 1, that is D itself is a simple region, B is 2, C is 3, D is 4. It's impossible to slice this in any number of simple regions. So what do you guys think? Think about it for a minute and come back. So when I'm looking at this region, there are ways that makes my life much easier to basically break this region into, but also there is a way that that requires the smallest number of setup. And let's see, one of them is this. You can have region 1 and region 2. Both of the regions are going to be vertically simple. Basically, you just have to solve for lower part of the circle here, upper part of the circle there, upper part of the circle here, and the line over here, and then you get the vertically simple region. Or you could just make this one to be this way, horizontally simple region, and that one vertically simple regions. So basically you can make it into 2 pieces of simple regions.